Hello student, let's discuss circular measure. This is a very easy question, right? Alright, let's have a look at this diagram, figure 6. Now let's read the question. The diagram 6. EDB is a semicircle. EDB, this is E, this is B. That means we are going to have the semicircle, right? Okay, let me highlight. This is a semicircle, right? Okay, this is a semicircle. Okay, the center is at A. This is center. Let me jot down the A. And then ADC. There's another circle, semicircle, center at point B. Right? Okay, so looks like we have two semicircle. One is at the center A, one is at the center B, is in pink color. Okay, so we have two semicircle. Okay, you are instructed to use a pi 3.142. Don't forget, don't use a pi in your calculator. Now you're asking to find the theta in radian. Theta in radian. Let's see how to find the theta in radian. So where is the theta? The angle theta is here. Let's clear it. This is the sector. Okay, this is the sector, then this is the theta. How to find? We don't have the arc length here. We can't find, isn't it? But it's okay. Let's figure out this way. I'm going to work out the, whenever you cannot have angle, always think about trigo. Trigo is for you to find the angle, alright? Okay, you work out, you want to use a trigo, you must work out right angle triangle, alright? So this is 6, right? So this one also 6, right? Since the AB is, this part is 6, right? This one is 6, right? So this one is actually the midpoint. Actually, you can draw like this. You can have a 60-degree angle. Equilateral triangle, right? This is equilateral triangle. 6 here, 6 here, here 6. Alright, so that means you can find the angle easily. This is 60. Or maybe you can find this one is 3. You use a cos alpha. Cos alpha is 3 over 6. You get half, right? So alpha is 60 degree, right? But if you can see that is equilateral triangle, so obviously theta is 120 minus 60, 180 minus 60, so it's 120 degree, right? This is 180. So we got the angle theta, but the question want the angle theta in radian. So it's 120 times 3.142 over 180 degree, right? So you have to write your answer in for significant figure, so that your answer for the next one won't be so different. The accuracy of the answer for the next question will be maintained. So I will get 2.0947, 2.094666, because I'm using 3.142, right? So it's 120 degree times 3.142 over 180 degree. So you'll get 2.0947 or 2.095, right? So if you use a calculator pi, right, your answer will be slightly different. You will get, for calculator pi, that means you didn't use 3.142, you will get 2.094395, something like that. So you get 2.0944. Here is 7 because I'm following instruction. Alright, so following instruction, you get this answer, not this answer. Alright, okay, so perimeter in centimeter for the whole figure. Perimeter, whole figure, there's a keyword. Always highlight the keywords. Perimeter, whole diagram. So let's highlight the path that we want. Okay, so we are going to solve it like this. Perimeter, we always whole diagram, this part, and this part, right? Alright, so that means we will find out the arc length, because we have the arc length here, arc length DC or CD, we have arc length DE, arc length, and here is 12, this is 18, this one no problem, so we just focus to this one, theta, so S equal to R theta. Theta is 2.09. Okay, we use our answer 0947. 2.0947. Right? So times 2.0947. 6 times 2.0947. So the answer will be if you okay, let's say we use 2.0947, this one we have to times times 2. This one is the same, isn't it? What I mean is this arc length, the green one and the purple one the same, so we just times 2 plus with the 18, right, for the perimeter, plus the 18. So okay, that's the answer for the perimeter. Let's write down for B. Perimeter is 6 times 2.0947 times 2 plus 18. So the answer will be slightly different with the answer given, is because the answer given not following instruction. I'm not sure why they are not following instruction, because the question say use a pi equal to 3.142, right? Okay, so just stick to the instruction, right? Now we're going to find the area of the shaded region. Area of the shaded region meaning that you have to focus on this one. The shaded is here in green color. Okay, make it darken. So that means you have to find area for the sector and segment. Okay, you have to find area for the sector here. This is a sector and the segment. So we have to find the area for the semicircle minus area of the sector and then minus area of the segment. So we have 3 steps to do. Okay, so let's find the area of the sector is 1/2. Let's say we use a circle, semicircle, pi r square, right? 3.142. This is a semicircle, and then okay, minus out 1/2 half r square sector, right? 60 degree. Half r square theta. Theta is pi over 180. Have to convert to degree, and then we have to minus out the sector and also the segment. Segment is 1/2 6 square times 60 degree times pi over 180, minus out the triangle, right? Okay, Triangle is 1/2 6 square sine theta. Alright, so if you press your calculator carefully, you will get the area shaded region is equal to 34.43 centimeter square. Make sure the unit is perfect, right? I think the answer given there is centimeter. It must be centimeter square. Okay, if you write the unit, make sure the unit is perfect. Okay, so that's all my sharing about the circular measure, right? Till then, bye bye and have a nice day. Okay, if I press a calculator for this one, area of the sector, area of semicircle minus area of the sector, right? So I will take this semicircle, which is 1/2 times r square times pi r square, right? Divided by 2. So this circle, I'm going to minus out this one. Let me highlight blue color. I'm going to minus out the blue color sector. Okay, the blue color sector here. This sector minus out already. This sector is 1/2 6 square r theta. Theta must be times pi over 180, right? Gives a 3.142. And then for the segment, this is a segment. I'm going to show you how I find the segment. This segment, the yellow one, I will have to figure out this sector. Okay, this sector, the yellow one, the sector, I will minus out the triangle. Okay, so I'm using 1/2 times 6 squared times 3.142 180, but I minus out the triangle here, this triangle. Okay, so it's 6 6 and then here 60. So the triangle is what? Half AB sine C. A is 6, B is 6. Sine angle between the 6 60 degree. So if you press your calculator, this one will give you segment, the yellow color region, this region, segment, area of segment. Okay, I will get the answer, which is, if I press the calculator, is 3.26354. Okay, area of the segment, 3.26354 for the area of the segment here. And then for the area for the semicircle minus out the sector. Semicircle minus out the sector, which is a green color here. Okay, so I will get the answer, which is, I will take semicircle minus out the sector. I will get the answer 37.704. 37.704. So this is the semicircle minus out the sector. Okay, minus out this sector. This sector, I use a black color. This sector. Alright, so I have to minus out this one also, right? So that means I take this one, I will have to minus out this thing, 3.26354. So my answer that I get will be slightly different. It's 34.44 centimeter square, because I'm using pi equal to 3.142. Right, the answer I get a little bit different from the answer given. That's all my sharing. Make sure you write the unit properly, because the answer there is centimeter, which is wrong. Okay, bye. Have a nice day.